Good morning. Today we're going to be implementing a word wrapping algorithm that comes from an interesting source and has a few interesting properties. We're going to use p5.js, and when we're done, hopefully we'll have something that works like this. Let's see. There we go. Here I'm dragging the margin over on the right, and you can see the paragraph of text is reflowing. It's quite satisfying. Now, it's not a particularly hard algorithm, and you'll see if you go to the page on line wrapping on Wikipedia, you'll see this version of it. By my count, that's just 7 lines if you ignore the complicated insert line break before word in text there. But it's fairly straightforward. This keeps a running count of how much width has been taken up, and if it goes over the end, then it goes back to the beginning on the next line, or inserts a line break so that later on something can pick that up. Interestingly, this algorithm works per word. The one that we're going to look at works per letter. And yeah, let me talk a little bit about that. This work comes from some work done at the Viewpoints Research Institute, which was Alan Kay's research base after he left Apple, I guess. And in 2006, it was granted some money for a program called Steps. Now, let me just pull over this quote about Steps. It gives you a sense of what they were exploring. Can you build a working personal computing system in 20,000 lines of code? And I find that vision quite inspiring. I did a bit of Googling, and by way of comparison, the Linux kernel is tens of millions of lines of code, more than any one person could read in their lifetime. So this is a really interesting question. Is there a high-level way of expressing what it means to be a personal computing platform that enables us to do it concisely and in a way that feels more human scale than perhaps the systems that we've allowed to grow at the minute? I really recommend reading their final reports. Spoiler, they didn't create one. We didn't end up with an operating system with 20,000 lines of code, but some interesting avenues were gone down. Especially interesting, I think, is the Nile graphics language that they invented, in which some 300 lines of a domain-specific language and 1,000 lines of compiler work gives a complete graphics package which is as feature complete as something like Cairo or Skier, which themselves have millions of lines of code. So I think that they are onto something. There is something interesting there. Reading through some of the reports, I came across some stuff about text layout, and I thought it was really interesting. So I want to share it with you and then see if we can implement it together. Let me go away. So here's I'll try and make that a bit bigger, but it is from a bitmap. Here's what they call particle and field text paragraphs in eToys. Over here are some rules. On the left-hand side are some rules that these eToys are following. and over here is a really interesting phenomena. The letters wander about as ants. They end up following the leader to join up into words. They line up, and it says here, moving the margin causes text to flow. And that sounds really interesting to me. Is there a way we can do this dynamic text formatting in a way that gives the letters control of what happens? If they just want to be in a paragraph enough, will they end up in a paragraph enough? So I thought this was interesting, and I've seen this pop out in a few of the talks that Alan Kay has done, and I thought it might be interesting to try and build it and see how it works in practice. One other thing we've got to go on is from a different report of theirs, is a set of rules that they've that they say that rules that comprise this layout system. And again, it's got those attractive promises of characters wandering and characters formatting themselves. I'm not sure they're that easy to read, and to be fair, the report does say this is an early stage and they haven't sorted out the syntax and they haven't quite worked things out. But by working through them, we can actually implement this algorithm, and maybe have a bit of a think about whether it's better than other approaches that we might take. So I'm sorry that code is small again. Again, these things are bitmaps of bitmaps taken from presentations from the Viewpoints Research Institute. I'd encourage you to go and search out those presentations yourself. I'll link to some bibliographies of those in the comments, in the description, sorry. The other thing they describe this as is, first of all, as an army of ants, each character being an ant, and I think that's quite an interesting and evocative description. But there's another description they use, which they talk about particles and fields, where the letters themselves are particles, and there are forces working on them that are across the whole thing, and in some sense the letters can sense out what is going on around them and make their own decisions about where to format themselves. Let's start implementing it and see whether we end up with something that's more concise, whether we end up with something that's easier to understand, and whether we end up with something that's more extensible than if we'd just done the adding up, see, Wikipedia way. Yeah, let's get going. So I'm using p5.js, which is a JavaScript project that comes out of processing, which is specifically designed for creative coding. I've been using it for a few weeks now. I'm really enjoying it. It provides a global set of behaviors and functions that make it really easy to get things up and running, visualizations and toy projects and so on. Yeah, it's really great. So we're going to use that. As I say, by way of a cheat, I've already got one version that sort of works here, but we'll try and build another one from scratch and see how far we get on. I've made a tiny bit of a start. Let me just get those rules, make sure those rules are around somewhere for us to look at. think I had them open in preview and then closed them, which wasn't good. Here we go. So I made a little bit of a start here in P5. You work on sketches rather than programs, which I quite like. A typical sketch has a setup, a draw function, and various event functions. Here we've got a setup, which is run when the program first starts. We've got a draw function that is run every frame, and mouse dragged, which is run when we drag the mouse. In our setup function, I set up the default font sizes, colors, size of the canvas, and just as a kind of starting bid, I've suggested that maybe we have a class called text container here, which takes the text that we want to format. I've also created an instance variable, I suppose a global variable called reformatting, which is initially set to the width of the window of the canvas that we've created up here. In the mouse drag, when we drag the mouse, we're simply going to change that reformatting variable. And in the draw function, we'll draw a rectangle to show where the margins currently are. Finally, we'll call the draw method on the text container. And if we look at the top of the file, that draw method currently uses processing's built-in text command to write the whole text to the screen. So if we run that, we'll get the start of what we're after. I can drag a margin this way, but obviously we haven't done anything to make it reflow yet. But that's looking good. So we've got a draw function here. We're also going to need a layout function. So let's give that a shot. In fact, let's see if we can understand any of the rules that the clever people at the Viewpoints Institute put in a presentation for us. So they are a bit hard to follow, but I did manage to figure out what they were talking about. So at the top we've got a rule called, which I'm treating as, let's call it a function. There's a function called layout. That layout has a bunch of kind of triggers on it when it's called. If the client contents are not empty, and here we come across the first interesting bit, is that it tells the successor of the first letter to place itself. So what this layout does is it puts the first letter in the right place, and then it calls place on the successor to the first letter. So the first thing we know is that we're going to need these letters in some kind of structure that lets us go get the successor and the predecessor. So let's make some letters, shall we? And we'll see. So let's make a new class. We'll call it letter, or maybe letterbox is a better word for it. Letter will do for now. In its constructor, it's going to take a single character and tuck that away as a property. We'll also put it somewhere on the screen. And I'm using one of processing's built-in randoms here. Random I always have to double check if X is width and Y is height. Yeah, they are, aren't they? Yeah, that's right. And we'll let this letter draw itself. We'll use processes built-in text thing, and we'll say draw your character at your X location and your Y location. Why is it complaining about that? We should do that, I guess. Yep. So now our text container should have a bunch of letters in it. Let's see. Let's do that. So this.letters equals array from text. I think I can do that. That'll give me each character in an array. And we can map that. We can map that character and make a new letter from it, like that, I think. And in our draw function, of course, we want to draw all those letters. So I'm not sure whether it's let or const here, but of this dot letters letter dot draw. I think that's right. So when we run this, we'd expect the text to be, all the letters to be drawn randomly all over the screen. Let's see if we can get that to work. There we go. So that's not an ideal layout, but it does get us, we have got each individual character being put in different places. Now we know from the layout rule here that tell client contents first successor to place, which is the rule here that runs after it has set the client contents of the first box to 0, 0. So we need a way to tell whether a letter is the first letter, I guess, and a way to get the next letter from a letter. And we can do that in the text container, but I think maybe we'll do it in the letter so that the letters have a kind of sense of the previous one and the next one. So what I'm going to do, once we've created this letters array, I'm just going to straightforwardly if I can type length, I'm going to use a old-fashioned for loop just to set the next and I don't think that'll complain when it drops off the end of the loop, so the last one next will be just undefined. And while we're here, let's doubly link these letters. So we'll put a previous in there as well. So that looks good. So we still should be just getting our random letters. Let's save actually. Let's save and run. Yep, we're looking good. So now back to these layout rules. So put the first one at 0 and then tell the first successor to place. Well, I think we can do something a little bit different here. Let's make a function called place and say if I'm the first one, first letter, this dot first letter, then my X should be 0, and my Y should be, now the letters draw from the top left, so we need some kind of line height thing here, and I've already calculated that down here, so line height. So if it's the first letter should now appear in the top left. When we run this, the first letter is A in our text, I think. Here we go, for Alice. We should see that in the top left, which we don't. Because I have not defined what it means to be the first letter. So let's just make a... and also I haven't called that function. Two good reasons it wouldn't work. This dot previous. Yeah. You haven't got a previous. If you haven't got a previous thing, you must be the first letter. Let's write a layout method here, which mirrors the layout rule that we found in this strange rule DSL from the Viewpoints Institute. So a layout function should probably take this dot letters, the first letter, and call place on it. So let's see, are we going to get our A in the right place? No. Oh, because we're not calling that layout anywhere. So before we draw the container, let's just tell it to lay out. Oh, now we've got an error. That's good, I guess. Line height is not defined. Okay, it is now. And there we go. We've got an A in the right place. Right there at the top left. We can still move our margin, doesn't do anything at all. So going back to the rules. So I think we've implemented the first part of this rule. The second part is to tell my successor to place. So what we're going to do is say this dot next place, and we're just going to check that there is a next. So let's see what happens here. Still got our A in the place, no errors, but the only thing that knows how to place itself currently is the first letter. So let's have a look what place has a look. Let's bring these rules across again. Can make them a bit bigger actually. I'd encourage you to look for the document. I'll link to it down below because these are quite hard to read. I think even sitting really close to them, they're very low res. So when I'm nil, return me. That looks like that could be some kind of recursive thing. It's typical that you see at the beginning of a recursive function. A kind of, oh, if I'm nil, then stop this process happening. And that sort of makes sense because we've got this dot next dot place happening here inside of place. We'll ignore that for a minute because we're not going to add any methods to nils. We'll find a different way of doing that. Always get my predecessors box and set my pivot to like predecessor's box plus an offset. Okay, let's do that. So if I'm not the first letter, this dot x equals this dot previous dot x plus, and we need to know the width of this character, which processing will give us by just text width. Let's just set that to 10 for now. We'll see what happens. And this dot y equals this dot previous dot y. Let's try that. Well, it doesn't seem to have done anything. The next letter we were expecting was an L. I think it might be there, but obscured by the A. So let's actually use this, the actual width of that letter. Is it there? Can I see that? I'm not sure I can actually. Ah, the text width of the previous character. So there we go. Now our L is right next to the A. And I guess we curse again. No, look at that. I'm a bit nervous about doing this. It is a tail recursion. But I don't think JavaScript will optimize that away, which means that every time we call next place, we create another stack frame, and eventually our stack frame will probably get too deep. But we won't worry about that at the minute. We have something that very respectably does our first line, which is great. Back to our rules. When rule place if after return. So this is saying if there's a new line. This is handling new lines. Let's ignore that for the time being. And let's get wrapping working first. So the next rule we have to care about are these two rules here. There is one simple one, which we've actually already implemented, I think, which is when the rule is not clipping the side of the box. Tell my successor to place, which is this dot next and this dot next dot place. But there is here, this is what's happening if it is clipping. Back to word start. So we jump down to this rule here. So let's make sure we've implemented that. So I just want to quickly tidy up a couple of things. This is our x extent or something. We can say get x extent. Let's try and make this a bit more readable. And then we can say this dot previous dot x extent. Yeah, let's just make sure that still works. It does not, because I haven't returned from here, I guess. There we go. Okay. So next rule is saying if you've gone over the edge of the box. So we can say if this dot x extent is greater than, what do we call our margin thing? Something like wrap at x. Then we need to do something else. Keep going. Let's just save that. One of the reasons I'm saving is that when I was playing with this before, it's quite easy to get into an infinite loop where you don't meet the exit condition of some rule, and then the browser tab will crash. So saving often is a good idea for this kind of thing. So let's see what our rules say. So our rules say jump to the, or fire the back to word start rule, which is this rule down here. And this rule says always the letter to move is the one at the start of word for me. That makes sense. So let's do that. So letter to move, and it would be const maybe, equals this dot start of word. So let's see how that's implemented. Well, that's specified, I suppose, in this rule system. Start of word. If my predecessor is nil, then return me. If my predecessor is white space, return me. Otherwise, return the start of word of my predecessor. So this is a nice little recursive definition here, which we can do. So if not this dot previous, return this. Else if this dot previous dot white space is white space, return this. So in other words, if you're the first letter in the whole text, you're the start of the word. If you're the first letter after some white space, you're the start of a word. Otherwise, and this is where we recurse, this previous dot start of word. So let's just implement that. Is we need to return there, don't we? So we're going to implement that get is white space, and I think the only white space we have at the minute is that. So, or I think we have that as well. So that looks good to me. So we've got the start of the word. Let's look at our rules again. So we're here. If it's this, right. So if that letter that you're trying to move is already at the start of the line, then it's at the start of the line and it's overflowed. So who knows what to do there, but so that's basically saying if this dot start of line then do something else, do something else. So get start of line, and I guess that's return this dot x is 0. Yeah. So what do we do with this letter to move? I wonder. Once we've got the letter to move, we position it at the beginning of the line, beginning of the next line, and then we tell its successor to place. So so this dot next wait, if it's the let's just do it exactly as it says. So if we're at the start of the line, the letter to move equals this. So I wonder if we can okay. If the letter to move is at the start of the line, then we do that. Else. So we do this letter to move right, no y equals this. So this is the start of my word plus line height. And this letter to move dot next. So there we go. Well, so I've added lots of thises in there that I don't need, which is usually the opposite of the mistake I make. So, and there we go. We now have that implemented. We can move this and it shrinks. No, it's not quite as attractive as those wandering characters moving all over the place, but maybe we can fix that. So if instead of Sorry, if instead of doing the recursion here, if we just returned the thing that's to be done next, we can do the recursion. We can do the looping outside of the place loop. I mean, we're pretty much done here, but let's see if we can do that and see if we can make it a bit more interesting. So if we say const next letter to place equals this dot next, and then at the very end of this method, let's say next to place. Well, let's just return. So we don't need that. We don't need that. And we say in this one, next letter to place equals the letter to move. And we've made it const, which is not reasonable for that, so it's moaning. And let's just save. Right. Now it's only placing the first letter. So where we're calling place, it's going to return the next one. So if we say this last placed one, next letter to place equals this dot letters 0, and we say this next letter to place yeah, so that actually so now every time it calls layout it will place a letter until we probably get an error for, there we go, now look at that. Was that what we were expecting? Oh, look. Ah. There we go. So now we get this. And it ends. So it's going to check that before it calls the next letter to place. So it should run until, bring that in, take it out. And then, yeah, that seems to work. We probably need a reset on this, which says reset, and we can just call this What have I done now? This dot. And then we want to call, when we drag the mouse to change that, we want to call container reset. And there we go. Yeah, so really we've taken these rules and we've ignored a couple of them. There's a place after return one that we've ignored, and there's a, I think we're implementing that one, okay. So any return characters that are in the text won't get handled currently. But that's it. That's the kind of the algorithm. And I think it's quite satisfying to see these things move. What I'd like to see though is them each letter doing its thinking independently. And it doesn't seem like we can do this while we're doing this, not next, but it looks like the layout algorithm is dependent on doing things in this order, whereas in the pictures that Alan Kay gave us, it sort of implied that it was organic. If anybody does have the original source code or can get hold of it for me, I'd be really interesting to see how it makes this organic. I'd be really, I think that would be really fascinating. Is it simpler than the thing we got off Wikipedia at the start? Well, I mean, clearly it isn't. But I guess the supposite the contention would be that this expresses word wrapping in a better way than an algorithm that understands that there are a certain number of columns in a page. That all this needs to understand is if it's trying to draw outside of the lines of the box, and that's a slightly different thing from knowing that you're doing columns. So I suspect that this algorithm will work better when you're flowing text around complex shapes and so on. Or at least you would need fewer changes to it to do that. And I guess that means that in a sense, perhaps it expresses what it means to wrap words a bit better. Maybe not, I'm not sure about that. In any case, I hope you enjoyed that. Take a look at the documents on the STEPS project from the Viewpoint Research Institute. There's lots of other interesting things in there. And I hope this was all technically okay for you. Let me know in the comments if the audio was too loud or the video was laggy or whatever, because I'm still working out how to do this stuff. and let me know if there's anything you want me to do a similar treatment on. I'll put some links in the descriptions to the finished versions of this that you can play with, and hopefully you'll dig up some interesting stuff yourself. Right, thanks for that, and bye-bye.